All right, so last section in the module, 7-6, natural logs, okay? We kind of talked about natural logs a little bit yesterday, but a natural log is a log. It just has the base with E. So whoops. So natural log is the same as having a log with a base of E. Now, where have we seen that E function before? Per. We talked about that yesterday. Okay. Bert.
Wait, the E isn't a number, it's just a verb.
It's a function.
It's a function.
Yeah. Yep. So, I kind of touched on this yesterday too. All right. That function E to the X, like if you were to just graph E to the X, it would look like an exponential function. Okay. That E is its own special function though. Like E is like 2.74 blah blah blah. Like it's its own kind of number function thing. The inverse of E is natural log. Okay? The inverse of E is natural log. Okay? Now, yesterday we also talked about natural logs and logs share the same properties. So just to refresh you all, let's talk about if you saw something like this. On problem number 1, it says, what is 2 natural log of 15 minus the natural log of 75? Well, again, I'm condensing to a single natural log. It's just the same as what we did yesterday. So this would be 15 squared divided by, because of the minus, 75. Well, what is 15 squared? 225 over 75.
Which is 3.
Which is 3. So, go ahead.
Do you ever have to write the E?
No, you can just put L in. Yep.
So how would I write that as an exponential?
We're going to talk about it.
That should be able to write it as an exponential.
Writing what as an exponential?
On natural log.
I'm going to show you in just a second how you can solve using log base E. I'll show you in just a second. Do we understand how the condensing properties are just the same? Yes? So verbally, let's do these quickly. On A, I would have the natural log of what? 7 times what? 5 squared. The natural log of 7 times 25. What is 7 times 25? 175. On B, we would have the natural log of what? X cubed over, and everything is squared there, right? So you would have the natural log of x cubed over 4x squared, which simplifies to the natural log of x over 4. Do y'all see that? If it can simplify, simplify it. Okay. On this last one here, we would have the natural log of x cubed times y squared times 5. Would I write the 5 in the back like that? No. How would I write this? 5 first, and then xy. Bless you. So, same properties that we learned yesterday, they still apply to natural logs. Y'all with me on that? I kind of flew through that because they are the same. Okay. Bless you. If you need to go back and look at that, you definitely can. All right. Let's get to the solving part, though. All right. Let's get to the solving part. If you are keeping up with your own notes, this section, we're going to solve natural logs first, and then we're going to solve E functions. So, in this part here, I went ahead and copied the part from the textbook just so you could see like how they walk you through this process. But I'm also going to go ahead and walk you through it too. So here it says, what are the solutions of the natural log of x minus 3 squared equals 4? Again, you want to ask yourself, is the natural log function by itself? In this case, yes. Is there anything being like added or subtracted out to the side or multiplied out front? No. So it's already by itself. So I'm ready to use its inverse in order to solve. What's its inverse? E, right? I just talked about that earlier. So, what did they do here in this step? What they did was they put an E on both sides.
But they don't show it.
They just didn't show it. I want you to show it. Okay? So, what happens with the E and the natural log since they are inverses of each other? They cancel each other out. So, you're left with this step right here. X minus 3 quantity squared equals e to the 4th. And then guess what? We just solved. Okay? From here, what did they do to both sides? They square rooted both sides. And remember, when you put in the radical, what do you have to have? Plus or minus. Going back to a couple modules ago, when you put in the radical, you have to have that plus or minus. So from here, they just added the 3 over to the other side, and then they typed this in their calculator. They did 3 plus e to the second, and then they also did 3 minus e to the second. On your calculator, how do you type in e? Second natural log. It's right beside number 4. Second natural log. It's right beside number 4. So on your calculator, you can type in 3 plus e to the second power, and you do, in fact, get the 10.389. They rounded here. And then if you do 3 minus e to the second, you get that negative 4.39. Okay? Lastly, you do want to check. You can see here, since they rounded, that's where they're getting that 4.003 from, but it's approximately the same as 4, right? If you didn't round, you should get exactly 4. Okay? So, moral of the story, if you see natural log, how do you get rid of it? E. Okay, Campbell?
So you are allowed to have like negative solutions.
Well, and it makes sense here because when you have a negative solution, what are you doing with that negative solution? You're squaring it, which makes it a positive. So, yeah. Great question. Anybody else got a question? So you can. So if you wanted to, Alex, instead of seeing ln, you can write log base e and do the circle trick. Did y'all hear me say that? Okay. So Alex was like, I kind of thought of it like the circle trick. You totally can. If you see natural log, write log base e and do the circle trick, it gets you there at the exact same time. Do y'all understand what I'm talking about? Okay. My mind, I'm like, oh, natural log, e. Like, I just know to do it. All right, let's practice some more. You got it. I know you can. Let's go. On A, what should you ask yourself? Is the natural log function by itself? Yeah, so how do I get rid of the natural log? E. This one's easy. The natural log and E cancel each other out. So you're left with x equals e to the second. What is e to the second? Nope. 3, 9. So, easy. Very straightforward. Let's look at B. This one's going to get a little weird. Is the natural log by itself? Yep. How do I get rid of it then? E. This is like the one I just walked you through. So you have 3x plus 5 to the second power equals e to the 4th. How do I start solving for x? Square root. I just put in the square root function, so what do I have to have? Plus or minus on that e to the second. All right. So we have to subtract the 5. So negative 5 plus or minus e to the second. And then what do I do from here? Divide by 3. So on your calculator, you're going to have to enter this in 2 times. Because you're going to have to say negative 5 plus e to the second divided by 3. And you're also going to have to say negative 5 minus e to the second all over 3. What did we get when we did plus e to the second? 0.79? It rounds up to 0.8? What about the minus, guys? It would be really awesome if everybody could type this in to make sure, A, you're doing it correctly, and B, we all are on the same page. Did we get negative 4.13?
Yes.
All right, Garrett.
So for these, do we check for extraneous solutions?
You should plug them back in, see if they work. You're typically only going to see extraneous when you have that quadratic, though. Yeah. But, I mean, it would be nice. I think they both actually do work, so it turns out nicely. All right, let's look at C. Uh-oh, what's going on with C? It's not by itself. Specifically, yeah, you got 2 natural logs here, so what do you have to do first? You got to compress them. That's right. Condense is what we used yesterday. What does that plus sign tell me to do? Multiply. So I have the natural log of 6x equals 2. Can y'all solve from there? Let's get it. That's what the e function does.
It's gone. Middle Eastern.
What'd you get for x here, Zach?
My calculator.
Okay, honey, so I have calculators over here that you could use.
I've been using Cody's.
Oh, perfect. What does x equal? 1.23. I'm tired too, y'all, but we got to get through this. Yes?
Yes.
Yes, let's go. Any other questions?
No.
Moral of the story, what do you do with a natural log? E. E. All right. So, vice versa, going the other direction. If you have an e in your equation, how do you get rid of that? You natural log. Okay? So on problem number 3 here, again, I copied from the textbook so you can see this process, but I'm still going to walk you through it. Same question you ask yourself from the very beginning. Is my function by itself?
No.
No. So you can see here, what did they do first? They subtracted the 2. From there, what did they do? They had to divide by 4 because the e function was still not by itself. Now, this step right here, e to the 2x equals 3.5, is the e function by itself? Yes. So from here, I'm going to get rid of the e by putting in a natural log. When I put in the natural log, these cancel each other out, and I'm left with 2x equals the natural log of 3.5. From here, divide both sides by 2, and you get your answer. Plug it back in and check. Okay? Let me reiterate. When you see an e, how do you get rid of the e? Natural log. Okay? Do we see where the natural log button is? All right, next to number 4. Solving for e is very straightforward. Get it by itself, put in a natural log, you're done. Okay? We good? We're almost done, guys. You're doing great. Let's keep it going. Let's do A, B, and C. I think we got 2 more slides. What's the first thing you need to ask yourself? Is the function by itself on A? Yes. What do I do? The quicker you answer me, the quicker we're done.
5. Hey,
Hey, what's up? Hey! You found
found
it!
it. Buried in a box.
Oh, where? Nutter's closet?
Nope, in the cabinet.
Oh.
Man, Mr. Martin, you're the best.
Mr. Martin is good.
All right, here we go.
So it's not 5?
I don't know.
Oh, could it be 5?
It could.
Like-
Oh, really?
Yeah.
Oh,
I'm
could
gonna
it be
go
5?
with a no because it's like a natural log. It's not, yeah.
We
I
don't know.
All right. Oh, this is really good. This is really good right here. I need to emphasize this.
It was really close.
On this question, when you solve for x, okay? When you solve for x, what do you have to do right here? Add the 2.
Mr. Bud not to
Yes, but
By
not
itself.
to the 12. Very good. So x equals the natural log of 12, like that's in its own thing, and then plus 2 to the outside.
Oh, it was close to 5. It was close.
Somebody needs to go somewhere. No, I'm just kidding.
So,
What is it? 4.9?
4.48. Go, Eric.
Oh, that did not round to 5.
You can get more benefit by making it here with no knowledge of what you're doing instead of 5.
What was it? 4 point what? 4.9? 4.8?
That is so close. He was close. We could run the 8 and then round that.
No, like,
Yes.
It's not how value is.
y'all tell Martin next class. It was 4.48. All right, let's look at B. Here we go. What do I do first?
Divide by 2.
Divide by 2. Got to get the function by itself. E to the negative x equals what? Natural log. So you get negative x equals the natural log of 10. Divide by that negative 1. Very good, Carson. So we would say x equals what? Correct, which is negative 2.3?
Yes.
Negative 2.3. All right, let's get C. What do you notice on C?
It is by itself.
Got to get the function by itself. What do I do? Subtract 5. So e to the 3x equals 10. Natural log it. 3x equals natural log of 10. Divide by 3.
You get 0.7675.
Alrighty.
So that'll.
All right. How are we feeling with the e function? Good stuff, right? That's what Carson asked me. He was like, I thought today was supposed to be like really hard. This is not super difficult. It's you have to know when to do what. Okay? So like on this next page here, okay? If it were me, okay, we're running out of time, I would take a picture of this and I would practice, right? But we can go over these just kind of verbally just to make sure you know what you're doing. All right? So let's look at number 1. What type of function is number 1? It's exponential. Okay? So how do you solve an exponential?
Log the same
You log it or same base, right? Okay. Would you use a natural log here?
No.
No. Okay? Don't even think that. When do you use a natural log? When you see an E. Okay? So here, for number 1, you would want to insert a log on both sides. Okay, number 2. You have a log. You have to condense first. Then what do you do?
No. That's a natural law.
You would not, listen, you would not use an E here because Because what does that word say?
Log.
Log.
Natural.
Not natural log. It says log. What do you do with a log? You circle trick. Okay? Number 3. Oh my gosh, what do you see? An E. So how do you undo an E? Natural log. Number 4, you got natural log. How do you undo that? E. Okay, that's what I'm saying. I just got done saying this. This is not a difficult concept. You have to know when to do what. You have to keep that straight. Okay? How are you going to keep this straight when you get to the test? You got to practice. Okay? Alex. Hey. Alex is asking a question. Let's hear it. Even if they have the same base? Yep, every time. All right. All right, you have for homework tonight 7.5 and 7.6 worksheet. You got to come get the 7.6 worksheet.